video is a tutorial on communication setup in VitalSim with a focus on configuring coded track and general I/O cards. This diagram shows a location with two controllers, one called East and another called West. Each controller has two cards installed, a coded track interface card and a general purpose I/O card. Coded track interfaces use a pair of wires to interface with a segment of track, allowing the track to be used as a communication channel. Signals can be transmitted and received from either end. In order to allow both sides to transmit and receive, transmission is time multiplexed. One controller transmits while the other controller receives, and vice versa. The signals transmitted by coded track are basically distinguished by the length of a DC pulse, which is transmitted continuously over the rail segment. Varying pulse lengths cause different codes to be received. If the track segments are shunted, which means short-circuited, the track will be unable to act as a transmission channel. Track interface circuits attached to the track will recognize this condition by the fact that the periodic code transmissions are interrupted. Physically, a coded track interface contains only two wires to drive or read voltage across a track segment, but logically, a coded track interface appears as the set of tags indicating that a particular code should be transmitted or has been received. Thus, there appears to be more logical bits associated with a communication channel compared to the number of physical connections. In contrast, general I/O cards transmit individual DC signals, which are physically and logically treated in the same way. An I/O card will typically have a set of inputs and a set of outputs, which can be mapped to user-specified tags. Now let's see how to set up these two different types of communication in VitalSim. In the track plan, I'll add an icon to represent each end of the coded track interface. The icon on the right will represent the East controller's interface, and the icon on the left will represent the West controller's interface. Before configuring these icons, we can initially verify the output of one coded track interface is not received on the input of the other end's coded track interface. At this point, the simulation is as if the coded track interface cards have not been physically wired to the track segment. So let's take a look at that in App Navigator. So we have the West side, and we're just going to confirm that when the West side transmits a code, the code is not received on the East side. So we'll look at what the West side is transmitting. The West side is transmitting a code 1 and a code 2, and the East side is not receiving a code 1 or a code 2. So this shows us that these two track interface cards are effectively disconnected from the track segment. So let's configure those icons now. I'll take the left icon and I'll associate that with the West side controller track interface. So you can see that just clicking on this track interface card populates the variables here to tell this icon that when this tag is picked, it should indicate that a code 1 is received, and so on. I'll do the same thing for the right side, associating it with the East controller, and I'll just stretch those icons out a little bit to prevent the track name from overlapping. So we can see here the icons are indicating that the coded track interface on this side is trying to transmit a code 1 and a code 2, but a code 1 and 2 is not received on the East side. And same in the opposite direction, the East side interface is trying to transmit a code 1, but nothing is being received on the West side. So now let's tell the simulation that these two coded track interfaces are connected to the same segment of track. We'll do that by holding Shift and then left-clicking each icon and selecting Set up Coded Track Communications. So that's all we need to do. Now these two icons should behave as if they are physically connected. So we see now that the codes transmitted from one side are still not received on the other side. And that's because the track segment is shunted. We can see that by the color of the track being red. That means that the track segment is shorted across the two pieces and no voltage can be transmitted down it. So in order to remove that shunting, as if a train is gone, we're removing the train now. Now codes transmitted from one interface of that track will be received by the interface on the other end. So we can see the West side is transmitting a code 1 and a code 2. The East side is now receiving a code 1 and a code 2. And we can click again and see that that transmission fails when the track segment is shunted. So now let's set up communication for point-to-point. I'm not going to do anything on the track plan for point-to-point communications. I'll just configure it directly, and we can verify in App Navigator. So in here, I'll go to Set up I/O Point Communications. I'll select the controller whose outputs we're configuring and the controller whose inputs we're configuring. Now let's use App Navigator to know which tags to choose. So you can see the West has a I/O card, and it has 3 variables that are outputs. That's WIO out 1, 2, and 3. So we'll type those in. And then we can see on the East controller, its I/O card has 3 inputs that are called EIO in 1, 2, and 3. So what we're saying here is that we've basically told the simulation that there's a single physical wire that connects between this output on the I/O card to this input on the other controller's I/O card. So we'll save and apply changes, close. Now we can go back to the West side controller and look at the values that it's putting out on those 3 I/O pins. So we can see it's putting out a 0, 1, 0, or dropped, picked, dropped, or false, true, false, however you want to describe that. We should see the same pattern received on the 3 input pins for the I/O card on the East side. So we see here I/O in 1, 2, 3, and everything's working as expected. So hopefully that was helpful. Thank you for watching, and we appreciate if you can like and subscribe. Please leave a comment if you have any questions about this video. Thank you.